And now you're saying this true. Okay, gets a bit tricky. This saying is it's true that you're sending it to everyone except yourself. If this was false, it means it's sending it to only yourself. If it's true, it means it's sending it to everyone except yourself. Weird, I know, but that's the way it works. Okay, so we've sent our packet off, all good. And that's it, we can finish. Not really. We have to make it control player equals num players. This way, when we want to only affect our player, we can go something like player control player. And therefore, this user can only affect control player, which is the one that they spawned. Anyway, we don't need that. I was just typing there for that sake. And then we increment num players. Otherwise, other people would be able to control your player, which would not be good. And we make spawned equal true, so this can't happen again. Okay, so this is very important at the end as well. Yeah. Okay, so we're done. We spawned our player. On the client side, we're doing a server right now. On the client, this would be exactly the same. There would be no difference whatsoever, except instead of saying server here, it would be client, or whatever you named it when you did this. So we're done here. All good. There's just one more thing we have to do for the server, and that is, what if we get a packet saying ID spawn player? Well, we're gonna have to go to our packet receiving switch up here. So if you remember, we have a big switch here, and we have a loop that goes through all the packets and identifies them, and then determines what to do with them based on their network ID. Okay, so as you'll see here, so as I said before, client has the same thing here, so it'll send a packet with ID spawn player to the server. The server will receive that it'll receive the packet will be called P, then it'll try and get the packet identifier, P. What this does here, get packet identifier, is it strips the timestamp. I already told you this. It does this function, which I already showed you how to do, and it strips that timestamp off it, because you don't need that. That's just for RakNet to order things itself. It puts it in a bit stream. Now, you'll see here, we have our bit stream here. It puts the data into the bit stream, which we're calling BSIN because it's an incoming bit stream. The data from P, and that is of length. I forget what this false is, but just write it that way anyway. Sorry, I'm not a genius on RakNet. I just figured it out that this works. We also want to define RakNet bitstream BS out, so that can be used in any one of these instead of defining it for each case. Alright, so now we're going to go down and we made a new case here. Originally this wasn't here. It's called ID spawn player. And basically what we're going to do is we're going to read the packets. We're going to spawn the player based on the positions and rotations given in the packets. We're going to give it the network ID, and then we're going to send out packets to everyone else to do it. So the first part, we define a vec3 player pos and player rot variable. These are the variables that the reads are going to be stored in. Okay, so after we've defined that, we want to ignore the message ID. We've already used the message ID to figure out we want to do ID spawn player, so we don't need it anymore. We don't want it to affect anything else. So we ignore the first one by going bsn.ignore, and then inside the brackets we go size of brackets RakNet message ID. Okay, done. Next thing we do is we read. We read by going bsn.read brackets, and then whatever we wrote in these writes will be stored in whatever variable you put in here. Sorry, here. So bsn read, it's reading the zeros that I put here in order into this vec3, but only the x component. So here we go, player position x, player position y, player position z, player rotation x, player rotation y, player rotation z. All reads. Okay, bsn.read brackets whatever variables you want to store it in. This does apply for anything, not just spawning player. You got to understand that. This is just the simplest way to do this. Spawning is just the simplest thing to do. So I'm explaining it like this. Now if you remember, the last thing we got to read as the same as the last thing we've got to write, is the player network ID. We need this, remember, we need the player network ID to be the same amongst every single computer for each particular object. Otherwise, things are going to get screwed up, and computer A won't know that this thing on computer B belongs to them, and all sorts of crazy stuff like that. So now we have all the information we need to spawn a player. And it's simple as creating a new instance of the player under num players with the position and the rotation as we declared here and defined in here by reading into them. Next thing we do is we set the network ID using the network ID manager. We set the network ID manager for that player that we just created. So set network ID manager bracket and network ID manager for player, num players. And then the final thing we do is we set the player network ID, which we read here, into here for that player. Alright, so that's it. We've read everything, we've spawned the player. Okay, now if this was a client, all you'd need in ID spawn player is that and this num players plus plus. But because we're a server, okay, a client spawns a player, sends it to the server, doesn't get anything back. A server will, say a client spawns a player, it tells the server that it spawned a player, the server then spawns the player, which is here, and then the server has to tell all the other clients that a player has been spawned, and that's what this next part is at. So we've read it, now we're going to redistribute all the information to all the other clients, except the one that just sent it. So we go ID equals ID spawn player, and then we're doing the same thing as we did down here. We're just writing the variables back into a bit stream and BS out, which we declared up here for this function. So we put in the type ID, which was defined as ID spawn player, putting the player position XYZ, yada yada, and then the player network ID. Exactly the same as before. We're just using the variables this time because that's what we know it is. Last thing we need to do is we need to send it. So server send and BS out. So we're sending BS out. High priority, reliable ordered, arbitrary 0. Now here you'll see, as I said before, unassigned system address means your own system. And it's true that we're sending it to everyone except your own system. Okay. Now this is where it gets a bit different. Now P and then system address, P arrow system address means that the system address that the packet came from. Because P is the packet, remember? As we received it here. And so Bob sent the packet, so Bob is here. And it means it's true that we're sending it to everyone except Bob. So it's true that we're sending all this information here, this bitstream, to everyone except the person who just sent it to us. We don't need to send it to them again, they've already got it. Okay? Now if this was false, it would mean we're sending it only to Bob. Okay? But usually, yeah. So we're sending it to, but we don't want to send it to Bob. He just gave us his information, he doesn't need it anymore. Okay, so the last thing we do is num players plus plus, because we've got to increment our number of players again. Because we've just spawned a player. Every time you spawn a player, you have to increment num players plus plus. Otherwise, you'll have two players controlling the same player, and then it'll just be retarded. And not to mention, you'll crash lots. So we're done. The server is completed. Okay, but nothing's going to happen just yet. There's one more thing we have to do. If the server's going to spawn the player, we have to put something in the main loop to actually spawn the player. So it's just really simple. If key hit, and I've made it key L here, server and spawn player. And that calls the server, tells the server to run this, spawn the player, and spawn the player and send out the information. Done. Okay? So that's our server. Completed. So now we're going to go and do the client. Alright, so client. Okay, so you'll notice with the client there's two things you'll notice that are very similar. The player class is exactly the same. There is no change. So just copy the player class exactly as you would. It's exactly the same as you would in a server class. The differences are always in the client and server classes. As you can see, we've got the same things. We've got our constructor called spawn player, and spawn player does the exact same thing. Alright, so we're going to skip all that. Just remember, don't forget to inherit. I'll say it for the 50,000th time. Okay, so we go to client, and in the client.h there's not much difference. We've got our network ID manager that we have to declare. We've got our player network ID that we have to declare again. We've got our type ID, which is a RakNet message ID that we have to declare again. Okay, so those three, you need to put them in. We also have these ones again. We have player instances. Now in the last one I had max players in here. Now I've got 10 in here. Whatever. Okay, just it probably should make it max players and define a variable, but it doesn't matter for now. Our control players, I explained before, we've got num players and we've got spawned, and of course we've got our function spawn player. So there's really not much difference between the client class declaration and the server class declaration when it comes to spawning a player. But there is differences in the functions. Okay, so we'll go through these really quickly because they're very similar, but there are some changes. So, of course, we first define spawned as false and num players as 0, as we did with the server. We go to our spawn player function, client spawn player. It is exactly the same. There's no change. We only do it if this player hasn't been spawned. So I'll just go through quickly. We create an instance. We set the type ID. We set the network ID manager for the player. We get the player network ID. And we assert it. Check if it's right. We write the bit stream with the type ID, the XYZ position, the XYZ rotation. We write the player network ID, and then we send it. So this code here is exactly the same as the server, except for two things. This will be server, and this will be server. No real technical difference, just a naming difference. Alright, so that's the same. Let's go up to our packets receiving. Okay, I explained this all before, so I'll just go over it quickly. Once again, most of this is exactly the same. The client receives a packet, its ID spawn player, it makes two variables with the vec3s with the position rotation. It ignores the message ID because we've already used it to figure out which case we're going to use. We read the player position XYZ into those variables, this variable. We read the rotation XYZ into this vec3. We read the network ID. We make an instance of the player based on num players and the positions and rotation that we just read. We set the network ID manager, and then we set the network ID. I don't know why I've got a plus there. Got rid of the plus. And then, so that part is all the same. Now, this is where it changed. In between here and numplayers++ on the server, we had a bunch of other code. And this was used to rewrite the bit stream and send it out to all the other players. So basically, a client spawns a player, it sends the information to the server, and the server sends it out to players. So the clients will never send out, if they've been given some information, they'll never relay that because that's the server's job. So they won't write another one here. All you got to do after you've done all that, all the reading and setting up the player with the network IDs and spawning the player itself, is increment num players. That's it. The last thing, the very, very, very last thing you have to do again is go into your main loop, and if key hit key L, which I've just made, we call the client spawn player function, and that's that. And really there's not much difference, as I said. It's just small difference in naming and small difference here, and that's really the only difference when it comes to spawning a player on a client or a server. or even more than just spawning, running, jumping, whatever. This will